You are looking at a can of paint thinner and light oil. To you, it is a lubricant, the blue and yellow fix for every squeak in the house. To the company that sells it, it is a $590 million water displacer wearing a lubricant costume. That can sit in garages, kitchens, and toolboxes on every continent. You have sprayed it on a stuck hinge, a rusted bolt, a jammed drawer, and almost every single time you called it the wrong thing. WD-40 is not a lubricant. It never was. The name is a confession hiding in plain sight, and almost nobody stops to read it. Water displacement, 40th formula. That is what the letters and the number actually stand for. Not a magic oil, not a miracle spray, but a chemical built to shove water off metal and walk away. The story does not begin in a garage. It begins in 1953 in San Diego, inside a company with a name most people have never heard, the Rocket Chemical Company. Their client was the United States military. Their target was the Atlas missile, the first weapon America built to carry a nuclear warhead across the entire planet. And that missile had a flaw that sounds impossible when you first hear it. Its outer skin was so thin that the empty fuel tanks could not hold their own shape. Left alone, they buckled under their own weight like a crushed drink can. Engineers had to pump them full of nitrogen just to keep them standing upright on the launch pad. Thin metal rusts. And rust on a nuclear missile is not a cosmetic problem, it is a countdown to disaster. Rocket Chemical was hired to find a coating that would drive the moisture off that fragile skin and stop corrosion before it could ever start. They failed. Then they failed again. The first formula did not work, and neither did the next, and neither did the one after that. All the way to 39 dead ends in a row. The 40th attempt held. That is the 40 inside the name. It is not a model number and not a marketing flourish. It is a chemist quietly counting his own failures until one of them finally worked. Here is what that 40th formula actually did. It crept into every microscopic pit and scratch in the metal, pushed the trapped water out, and left behind a thin, oily film that sealed the moisture away from the surface. Displaced the water, blocked the rust. That was the whole job. Nothing more. The same can now rattling in your kitchen drawer was engineered to protect a weapon designed to erase a city in the coldest years of the Cold War. But if this was a guarded military coating sprayed onto missiles, how did it ever end up under your sink? The answer is theft. The workers at Rocket Chemical noticed something on their own time. The stuff they were spraying on rockets also freed the rusted bolts on their cars, quieted the squeaks in their doors, and unstuck the seized chains on their kids' bicycles. So they stole it. Employees smuggled cans out of the plant in their lunchboxes, one at a time, because the product was simply too useful to leave behind at work. The bosses could have locked the supply cabinet and ended it there. A man named Norm Larson ran the company, and he saw the theft for what it really was. It was a free market test, and the product was passing. So he did the opposite of locking it away. He poured the 40th formula into an aerosol can and sold it to the public in 1958. This is the real answer to why it is used almost everywhere. WD-40 genuinely displaces water, creeps deep into rust, and frees seized metal better than almost anything at its price. It is also non-conductive, so people spray it onto wet electrics without a second thought. It does that one narrow family of jobs so well that people quietly assumed it must do everything. That assumption is the costume. A water displacer got treated like a universal lubricant, and the label never once corrected the mistake. It simply sold more cans. For half a century, the company called the exact recipe a secret. Then, in 2009, a magazine decided to put that claim to the test. Wired sent a single can to a laboratory and ran it through gas chromatography, a machine that separates a mixture into every individual chemical inside it. The secret sauce came apart in front of them, and there was nothing secret about it at all. The principal ingredients were ordinary alkanes, the plain carbon chains running from 9 to 14 atoms long, carried in common mineral oil. That was it. No classified compound, no rare science, no vault of hidden chemistry. Let me translate that into things you already own. The mineral oil is the same base you find in baby oil and in Vaseline. The alkanes are the same slow goo that drifts up and down inside a homemade lava lamp. Strip away the mystery, and the can is mostly mineral spirits, which is paint thinner, carrying a little light petroleum oil. For decades, you were paying for the legend, not the molecules. But here is the flaw that the label will never print for you. That paint thinner is a solvent, and a solvent has one defining purpose. It evaporates. Spray it on a hinge and the liquid vanishes within minutes. What it leaves behind is a film thinner than a single human hair, and that film is far too weak to do the job you actually bought it for. A true lubricant carries a load. It stays parked between two moving pieces of metal and holds them apart under pressure, again and again. A fast-evaporating solvent cannot do that, because within a few minutes there is almost nothing left on the surface to carry anything. Watch what that means once it leaves the can. A cyclist sprays WD-40 onto his chain every single week, because the label says lubricant and the chain goes silent the moment he does it. Then the solvent evaporates. The hair-thin film left behind gets crushed the instant the chain bends around the gears at speed. Road grit sticks to the residue, and now he is dragging sandpaper across his own drivetrain with every turn of the pedals. Within months, his chain had stretched 40% faster than it ever should have. His cassette looked like someone had taken it to a sandblaster. The spray saved him 3 minutes a week and cost him the entire drive system of the bicycle. A ruined chain is only money. The next mistake is measured in something worse. Spray that same friendly can onto a brake rotor, and the friction that stops you simply disappears. The pedal or the lever goes soft under your hand. Your stopping distance doubles, on a road where a doubled stopping distance is the whole difference between a near miss and a funeral. And the damage does not stop at the moving parts. That solvent attacks rubber the same patient way it attacks rust. Spray it near the seals around your car doors, and the gaskets slowly crack, shrink, and turn brittle. The window tracks stiffen. The same chemical that freed a frozen bolt is quietly eating the barrier that keeps rain out of your cabin. The worst part is that you cannot see it happening. The fix costs you a new seal. The spray felt like it cost you nothing. And the damage stays completely invisible until the first hard storm, when the water finally finds its way through. Then there is the can itself. The safety data sheet calls it extremely flammable, and it means every word of that. The vapor is heavier than air, so it does not rise and drift harmlessly away. It pools and crawls along the floor, hunting for any pilot light, water heater, or stray spark in the next room over. A flame that can never touch directly can ignite that invisible trail and send fire racing back along it, straight toward your hand and into your garage. Swallow it and the same sheet warns of chemical pneumonitis. That is the lungs filling and inflaming as the solvent burns them from the inside. The can that silences a squeak carries a genuine warning about ending a life, and almost nobody reads that part either. The company knows every bit of this. And that is the detail that finally gives the whole game away. Right beside the original can, WD-40 now sells an entire specialist line: silicone for rubber, a clinging gel for the surfaces where liquid runs off, a dedicated bike lubricant for the very chains the original was destroying. A senior scientist at the company, Chris Aiello, calls the multi-use product a one-can wonder, and then admits in the same breath that specialists exist for a reason. He is right. They built a second product empire whose only job is to repair the things the first can was never able to do. Yet the blue and yellow original never changed. It stayed on the shelf, still wearing the word lubricant, still promising a unique blend that the chemistry inside it cannot deliver. So why is it used almost everywhere? Because it does one thing brilliantly, and it was sold as though it did all things. The formula that walked out of that laboratory in 1953 has never been altered since. The chemistry is fixed, tested, and fully public now. The only thing that ever really changed was the story wrapped around the can. A missile coating became the most trusted spray in your house through one quiet trick. It displaces water, it frees rust, and it protects thin metal so well that you forgave it for everything it was never built to do. The company never patented the formula, and it never needed to. The real product was never the oil in the can. It was the belief that a water displacer could be a lubricant, and you bought that belief every time you reached for the trigger. Now you know what you are actually holding. Not a lubricant. A solvent in a costume, born on a Cold War missile, and hiding in plain sight on the shelf in your garage.